Hello and welcome back to section 9.1. In this video we'll be using example 2 to demonstrate how to find the centroid of a volume, and because this is a homogeneous solid, which means it has the same material throughout, it also will be finding the center of mass and likely the center of gravity. Alright, so over to the visualizer. So this shape, I've redrawn it here, is symmetric about this xz plane and this yz plane. Anytime you have symmetry, that means your centroid will lie at 0. So if I sliced it using this yz plane, the left half and the right half will be balanced. So that means that in the y direction, it's 0. Same thing if I slice it with the yz plane, I'll find that the back half and the front half are the same, which means that the centroid in the x direction is 0. So the only thing we need to find in this is z bar. So z bar, we've also already established that this is homogeneous, meaning that we can just do volume. So we're going to integrate some partial piece of volume per volume integral dv. Now we could go and draw a little cube in here and try to integrate, but because of all the symmetry and also we have circular shapes, it's a little easier if we use an integrating disk. So let's draw that disk down here. So basically we're just going to stack up a bunch of these disks. I'll give it some thickness, even though that thickness is going to be some infinitesimally small dz. This will have a radius, and the area of this, the volume, so the volume of this is just the volume of a cylinder. So it's pi r squared dz. R is related back to this equation here. So this equation is written in z equals, but we need the radius to be either in the y direction or in the x direction. So because of the way I've drawn it, I'm just going to say that it's y. So we want pi y squared dz, but you could also do pi x squared. It doesn't really matter. Actually, no, it does matter. We have a y up here, not an x, so we do need to do y squared for the radius. Sorry, we need to do the radius as y, because we have the y up here. So that means, in order to actually format this equation, we're going to find out that we're going to have to do some algebra up here. But we're getting ahead of ourselves. Okay, so let's integrate z, and then our dv becomes pi y squared dz. In the z direction, we're going to go from 0 to 2. From 0 to 2. On the bottom, we're also going to go from 0 to 2. We're not going to have the z, but we're going to have the pi y squared dz. These pi's are both constant, and they will cancel out. I can basically move both of them into the front, and then they cancel. So we don't actually need those. So we are left with integral from 0 to 2, z y squared dz, integral, this should be to 2 over here, 0 to 2 y squared dz. So we could just integrate as is, but what we would like to do is, if I can rewrite this equation, because this is an equation with y and a z in it, I can rewrite this equation such that I can plug in a z here. It makes my integration easier. So let's do that next. So we have z equal to 1/3 12 minus 8y. Rearrange that. So we'll have a 3z equal to 12 minus 8y. And you just kind of keep working until you get this all cleaned up. Alright, so you should get y equals to 3z, or this is a z, minus 12 over a negative 8. We're going to plug this back into this equation, so these are going to be y squareds. So let's go ahead and find y squared. So that's going to be our 3z minus 12 over negative 8. And you could just plug it in as this squared, but I'm going to expand it just to make the integration easier. You're going to find that that is a 9z squared minus 72z plus 144 all over 64. All right. So now, sorry about that, I jumped the gun on that. Let's bring this equation back down. We have z prime equal to integral 0 to 2 z times y squared. So I'm only going to bring over the top piece because I'm going to have a negative 6. I'm going to have a 1 over 64. I'll just put them out here for now, just so you see where they came from. But I'm going to have a 1 over 64 on both pieces. So they're going to cancel out. These are just constants, so I don't need them. And you're going to get 9z squared minus 72z plus 144. And if you feel comfortable doing it without expanding, go for it. All right. So then we're going to, basically what's going to happen is this is going to go away, and it's going to make this a third and a squared and a z. So you're just going to distribute that in there. So then you integrate this. Not too hard to integrate. The 64s will go away, and I will get 9z to the 4th over 4 minus 72z cubed over 3 plus 144z squared over 2 from 2 to 0. Down here, we'll get 9z cubed over 3 minus 72 z squared over 2 plus 144z, all from 2 to 0. Once you do all of that math, you should find out that you have 132 over 168. Which simplifies down to 0.7857 feet. So, sorry for the freezing. If we think about that, let's just kind of double check that we didn't do something wrong. So, about 3/4 of a foot, so about 0.8 feet. 0.8 feet. So, if we were halfway up, something would be wrong. We shouldn't be at 1 foot. We should be below 1 foot, and we are. So that makes some sense. We're not outside the shape, and we're not over halfway in the z direction. So this number seems sound. All right. If you have any questions, feel free to contact me.